Hello, we are Keeping the Ball Rolling, made up of myself, Daniel Ayala,
Wyatt Klein,
and Brad Haig.
And welcome to Team 6's presentation for the second stage of our design process for our Battle Frog Rube Goldberg machine.
We will begin by outlining where we are currently at in the development of our project. We will then discuss patents related to our Rube Goldberg proposal and how they helped us decide the best route of action throughout our development.
The team will also discuss the process and results of our concept generation and selection, as well as the possible flaws of our chosen solutions and the corresponding solution to those flaws.
Lastly, we will outline our financial model and our investment proposal to VT Incorporated. The team regrouped and changed the deadlines in order to better meet the manager's specifications. The identification of customer needs and target specifications were the same because we already completed these tasks. The team decided to extend the timeline of design for manufacturing, economic analysis, and the prototyping in order to better ensure a design for our Rube Goldberg machine. After reviewing the Gantt chart, the team wanted to better organize the relationships between tasks. So a design structure matrix was created in order to establish the sequential and parallel tasks.
The team researched intellectual property related to the project in order to gain a better understanding of the patents that could help or hinder our options for station solutions. A total of 5 patents were selected and logged, taking note of the key features of each, as well as the corresponding limitations and ideas gained from each. The team gathered that we may be limited on the amount of competitive interaction our final proposal contains, the type of construction used for a screw-type elevator, the method of folding motion for a trapdoor, as well as the construction method for creating a launch ramp. However, the team learned that user interaction could be beneficial for entertainment value in the overall final solution, as well as gaining ideas for modular screw construction, ramp construction, and trapdoor folding methods.
The team began concept generation by brainstorming 10 possible solutions for each of the 3 stations. We decided as a team to have Station 1 bring the ball to a greater height, thus adding potential energy to the system. Station 2 was decided to take advantage of the potential energy of the system in some way, shape, or form. Lastly, the team decided Station 3 could be anything that would wrap up the motion of the ball. Seen here is a snippet of some of the station's ideas for Station 1, in which the ball's potential energy was created.
Once the team developed 10 potential solutions for each station, with 30 total potential solutions, we began concept screening. First, we determined the selection criteria we would use, which was based on our team's established specifications. We then rated each potential solution with pluses, zeros, or minuses based on how well the solution optimized each of the selection criteria. Last, the potential solutions were ranked according to their net score, with the positive net score solutions continuing on to the next phase of concept selection.
For the potential solutions that were eligible to continue, concept scoring began. We chose 5 or more selection criteria based on our team's established customer needs and gave them weights of importance. As you can see, affordability and educational aspects were given the largest weights, as these 2 criteria were decided to be the most important for our Rube Goldberg machine. Each potential solution was then given a rating of each corresponding criteria, which was then multiplied by the criteria's importance. These weights were then summed for each potential solution to determine the best concept to begin developing. As you can see here in our example, the Archimedes screw was determined to be the best possible solution for Station 1.
The team followed identical paths to generate, screen, and score each possible solution for each corresponding station. In the end, we determined that the Archimedes screw, dual ramp, and trapdoor tubing were the best possible solutions for stations 1, 2, and 3, respectively. After we determined which solutions would be best to develop, we created CAD models, of which you can see here.
In order to further the concept selection, the team put together a failure mode and effect analysis. We were concerned about some of the aspects of the designs. For instance, on the ramp, the ball would sometimes roll off the track and ruin the flow of the machine. In order to fix this, the team decided on using guards in the next iteration. Some concerns for the screw was that the ball would become lodged in the screw, and the screw did not properly align with the ramp. In order to fix this, the team wants to increase the height and the diameter of the screw so that the ball will not get stuck and continue throughout the machine. The major concern of the trapdoor was that the opening would not close and the next ball would fall through without answering a question. In order to fix this problem, the team decided to do further tests with their Arduino and make sure that the trapdoor is functioning properly. These issues range in severity and will be addressed accordingly. Faults that will delay the process, as those previously mentioned, will be taken care of before aesthetics are addressed.
Based on cost estimates for production and startup requirements, we have concluded that an initial investment of $10,762.50 will be needed to fund our company. This was determined with a $48 selling price, leading to a quarterly revenue of $20,016. After taking into account operating costs, a quarterly profit of $9,273.50, the investment will be returned in one lump sum payment at the end of 12 quarters, totaling out to $15,344.75, which results in a 12% annual return on investment for VT-EPS.
In conclusion, we reevaluated our current progress and updated our Gantt chart so that it is accurate. We have researched related intellectual property and selected patents related to our designs, determining limitations and gaining ideas for each.
We have also utilized concept screening and concept scoring to select our final solution, consisting of a screw-type elevator station, a ramp station, and a trapdoor station. These stations were evaluated through the use of failure modes and effects analysis to prevent customer dissatisfaction or harm.
Finally, our team performed an economic analysis indicating that an initial investment of just under $11,000 will be required, which will be repaid at a 12% annual return on investment rate in one payment of $15,234.75 at the end of 12 quarters. We feel that this presents a very good value for VT-EPS to consider investing in, and we look forward to hearing your thoughts on our progress and investment proposal.